While going through the reactions and compounds of heavier group 14 elements, we have seen that the compounds that contain silicon carbon and silicon oxygen bonds are stable and important. High molecular mass polymers called silicones contain long chains of SiO bonds backbone with organic groups attached to silicon. The properties of silicons are determined by the chain length, the type of organic group, and the extent of cross-linking between the chains. Without cross-linking, silicons are waxes or oils, but when cross-linking takes place in silicon-oxygen bonds, it can produce flexible materials used in sealants, gaskets, car polishes, lubricants, and even elastic materials and plastic substances. The structure of a linear silicon polymer is similar to that of the quartz, but when two of the oxygen atoms attached to each silicon atom are replaced by the carbon atoms of the organic groups, such as the methyl groups. As shown in the figure, the terminal silicon atoms are bonded to three methyl groups. Silicons can be oily, waxy, flexible, or elastic. So many properties are adapted by the silicon depending on the chain length, extent of cross-linking between the chains, and the type of organic group. So we now will see the figure in which silicon atoms are replaced by the carbon atoms of the organic groups of methyl groups. In this figure we see that silicons are long chains of alternating silicon and oxygen atoms while terminated by methyl carbon atoms. Now we'll go through the summary of the group 14 elements and their compounds. The group 14 elements show the greatest range of chemical behavior of any group in the periodic table. Now, because the covalency decreases with increasing atomic size and greater than expected ionization energies due to increasing in Z effective, the stability of +2 oxidation state increases from carbon to lead. The tendency to form multiple bonds and to catenate decreases as the atomic number increases. The stability of the carbon tetrahalides decreases as the halogen increases in size because of the poor orbital overlap and steric crowding. Now, carbon forms three types of carbides with less electronegative elements: ionic carbides, which contain metal cations, methide or acetylide. Anions also are present, interstitial carbides, which are characterized by the covalent metal-carbon interactions and are among the hardest substances known. Third type is covalent carbides, which have three-dimensional covalent network structures that make them extremely hard, high melting, and chemically inert substances. Consistent with the periodic trends, metallic behavior increases down the group. Silicon has a tremendous affinity for oxygen because of the partial silicon-oxygen pi bonding. Dioxides of the group 14 elements become increasingly basic down the group and their metallic character increases. Silicates contain anions that consist of only silicon and oxygen. Aluminosilicates. They are formed by replacing some of the silicon atoms in silicates by aluminium atoms. Aluminosilicates with three-dimensional framework structures are called zeolites. Now we come to nitrites, which are formed by reacting silicon or germanium with nitrogen. The bond is strong, hard and chemically inert. The hydrides become thermodynamically less stable down the group. Moreover, as the atomic size increases, the multiple bonds between all to the group 14 elements become weaker. Silicons which contain silicon oxygen backbone and silicon carbon bonds are high molecular mass polymers whose properties depend on their compositions. Now we will have some problems based on the equations to reactions which have the given products in their solutions given below. The equation given is lead reacting with chlorine, and this will give the product, that is lead chloride, and the solution is also given hereby. How we can classify this type of reaction using the periodic trends in their atomic properties, thermodynamics, kinetics, and on this basis they explain why they observe this type of reaction products. So here we can give the explanation for the formation of lead chloride, that lead is a metal and chlorine is a non-metal, that is a strong oxidant, and we can expect a redox reaction to occur in which the metal acts as a reductant. Although lead can form compounds in +2 and +4 oxidation states, Pb4 plus ion is a potent oxidant, that is due to the inert pair effect. Because lead prefers the +2 oxidation state and chlorine is a weaker oxidant than fluorine, we expect lead chloride to be the product. Now for the second type of reaction in which the metal silane reacts with water. This is the reaction of water with a metallic silicide which formally contains silicon 4 minus ion. Water can act as either an acid or a base. Because the other compound is a base, we expect the acid-base reaction to occur in which water acts as an acid. Because Mg2Si contains silicon in its lowest possible oxidation state. However, an oxidation-reduction reaction is also a possibility, but water is a relatively weak oxidant, so an acid-base reaction is more likely. The acid here can be considered as H2O. It transfers the proton to the base Si4-, which can accept 4 protons to form SiH4. Proton transfer from water produces OH- ion, which will combine with magnesium 2 plus ion to give magnesium hydroxide. This is the explanation for the product form, that is silicon hydride and magnesium hydroxide in this product form. Now we see the third equation, that is germanium dioxide reacts with hydroxide. So now the type of products formed are explained on the basis that we expect germanium dioxide to be amphoteric. Because of the position of germanium in the periodic table, it should dissolve in strong aqueous base to give an anionic species analogous to silica. Now the exercise 2 contains in which we have to predict the products of the reaction and write a balanced chemical equation for such reaction. Now lead oxide is given, which product it will form. So PbO2 will give PbO, lead monoxide, and liberates oxygen. Then germanium chloride with water forms germanium dioxide. Tin with HCl gives Sn2 plus ion and hydrogen. So we have to give a balanced equation likewise given here in this exercise. Now we come to the problems based on the structure and reactivity, the basis for explanation of the products formed in all these exercises of the balanced chemical reaction to indicate what we will prepare for each compound. So these are the different reactions, and the reason for the product formation has to be given on the basis of their structure and reactivity, and their solution is given on this answers. Now the last page is for problems based on the various form of compounds and the elements of group 14, that is a carbon group. Likewise, here we see some of the very important questions and general questions, and like why it is oxidation state of lead +2 is preferred rather than +4, and similarly group 14 element is least stable in +4 oxidation state, as this has to be explained, and chalcogens, then heavier group 14 elements, then questions related to the bonding, different type of bondings of these various compounds of carbon and other elements.